Hi everyone, I'm Rosie. It just makes me so happy to see all of you here. Please, today is for you. Whatever you want today, just let us know. It's about you having fun and getting access to our great world of science. So we thought it would be good to give a little quick overview of some areas of research here at the university that you may not see today, because as much as we can show in one day, this university spends $1.4 billion on research every year. And so it's impossible to bottle up $1.4 billion in one day. But so what I'm going to do today is I'm actually going to focus on these different 5 motivations within research here at the university. And I only have like 6 minutes. So I'm going to go pretty fast. But at the end, I'll give you a URL where you can download this entire presentation, which has links to YouTube videos and news articles having to do with all the research that I will talk about. So first of all, one of the thrusts here at the university is understanding, preventing, and treating brain damage. So 2 really cool projects, the first 2 up here, work with how we have concussions, and these can result from football, from any other sort of things. The first one actually looks at the ways that the forces dissipate within a concussion-inducing collision. The second professor, Professor Arruda, within the Mechanical Engineering and Macro department, she actually builds new helmets that are reusable and able to withstand and dissipate the force of concussion. So if you're a bike rider like me, you know that if you drop your helmet too many times, you're not supposed to use it anymore. I've had to buy a lot of helmets for that. And she wants to make it so that you can drop a helmet and it still retains all of its functionality. The next one, Professor Cynthia Chestick, what she works on is neural implants in the brain. So she actually makes microchips to go in the brain so that they can better connect to prosthetic limbs. Next, Professor Yusik Yoon is actually trying to map the entire brain as a circuit. So think about like a computer network of the brain. And then finally, there's a program through the medical school here working on deep brain stimulation to try to return functionality for patients with Parkinson's or other limiting types of disorders. So again, you will get this entire presentation where you can click on all these links and see all the YouTube videos and all of the things. Next, and this is something that's very much akin to what I do, mimicking nature in the human body. So one professor here, what he's trying to do is 3D print parts of the human body. So a part of regenerative medicine is you can print a scaffold, essentially. So think about the scaffolding that you see outside of buildings where you could essentially build stuff around it and things. So imagine if you could print a scaffold and let your body grow the tissue through it. And so that's how we might be able to get somebody who's lost an ear, a new ear, by printing a cartilage scaffold and letting the tissue grow around it. And so this professor put together an entire video talking about whether or not one day we could potentially 3D print the entire human body. Next, so I don't know how many people the words open source means something to, but I'm a computer programmer, so it means a lot to me. So what open source means is that it's not patented or anything like that, where somebody can just go online and download the design for it. And so this next professor, what they did is they created this very cool bionic leg. And then they made all of the designs available online. So anybody could essentially go and download the designs and build it. And that means that it's going to be a lot less expensive for people to get that sort of prosthetic, as well as other people can try to innovate with it. Professor Kotov does a million things, but one thing that he does is he tries to mimic the enamel that you see in your teeth and try to see, because your teeth are a pretty robust material, and try to see how we can apply that to other regions. Wei Lu is actually trying to make a computer that mimics our decision-making process in our brain, which you think we make decisions like it's nothing, but we've been learning it for many years. And a computer has to make decisions based upon what we tell it to make decisions on, and is not as robust as how we make decisions. And then finally, this person, they have this really cool robot. It looks like a little ant, and it scurries around everywhere. And they're using the hinges within that robot to kind of mimic the hinges within different bug-like species. And so that can have a lot of different applications. Next, protecting internet security and privacy. These are actually very cool to look into. So there's one group here. They actually have created an app that reads through the terms and conditions for you. and tells you if there's anything predatory or concerning within the terms of and conditions. And they use machine learning, which is a technique where essentially you teach the machine to make guesses based upon what it's seen in the past. And so that's Polysis. And then Roya Ansafi, what she is doing is she is looking at governments that restrict internet access. So there's a lot of governments around the world that censor the internet, and sometimes it's really hard to detect whether or not the page that you're on is being censored. And so she has created an infrastructure to tell when a page is being censored by an outside source. Finally, and then we have Alex Halderman. What he's trying to do is essentially, you know in all those really weird 90s movies that have everyone's entered into the digital realm where it's all of these green and black things all around it, and it's kind of like, yeah, exactly. And so what this professor is trying to do is essentially that, map the internet in a way that we can kind of have a readable source, like we have Google Street View. And so imagine in Google Street View, you can go from one place to another pretty easily. Imagine if you could see what internet pages are connected to each other and how they all relate to each other. And then finally, and this one's a little more for the mathematicians in the room, Chris Peckart, what he's done is he is looking at lattices for cryptography. So cryptography normally is based upon some sort of mapping of one set of variables to another. Now imagine if you can take that set of variables and instead of making it a one-dimensional set of variables, make it a 3 or 4 or 5-dimensional set of variables. That makes it much harder for somebody to decode, as well as much more robust for security. There's a lot of people working on anticipating natural disasters. So I really love, there's a lot of work done by Dmitry Zekos. I'll just go down a couple right now. What he does is he flies drones into areas that have experienced natural disasters and models what's happened, because oftentimes these areas are not accessible for humans, but you can throw in a drone and see, okay, what is the effect of this landslide in this area? How can we tell what area is going to have a landslide next? And then with Seth Gukima, he's trying to use predictive mathematical models to figure out where it's going to suffer from an outage based upon a hurricane. And then back up to the top, there's a person, what they do is they try to outfit drones to firefight so that we don't have to send all of the human lives into the fires. This is why the robots will at one point come up against us, so that we're sending them into fires for us. And then finally, windshield wipers. You can actually predict where flash floods are going to occur based upon how often your windshield wipers are going. And so this professor is looking into how we can track people's windshield wipers as a predictive measure for where a flash flood is going to occur. All right, my last slide, and this is when I was going through all of the different web pages. Every single department has this phrase somewhere, a big data approach to. And what a big data approach to basically means is we're going to take a huge amount of data and try to look at the correlations or causalities within the data. And everyone is doing this right now. It's a big buzzword. So one professor, what she's doing is she's looking at patient and physician data, because we have the medical school here. There's a lot being done with it, and trying to figure out when a doctor is going to burn out, because doctor burnout is a huge problem within the medical community. Another one in anesthesiology is actually saying, okay, if people are wearing Apple Watches, can we use that data to be able to figure out how to better tailor their patient care? So imagine if you were able to give your physician the access to your Apple records, and they could know better how to treat you. And then James Grothberg, what he wants to do is he wants to map all of the tissue structures using big data based upon patients. And then this is kind of the musician love in me. This is a joint project in the math and the organ department. And what they're doing is trying to see how the brain responds to music and figure out how we can map the different responses to different types of music, different rhythms, different beats, and see how we actually process it. And then finally, Karthik Durasamy in the aerospace department is looking at how we can use big data for turbulence. So I just went through a lot in about 2 seconds. So here are the things. Write them down. So first of all, if you want to download this presentation, go to tiny URL /react-researchprez, and you will get this exact thing. You can download it as a PowerPoint. You can click on all the links, have all the fun. I also created a YouTube playlist with all the videos that are embedded in this presentation, and that's React-research videos. And then, excitingly, the university sends out a monthly research newsletter. So if you want to sign up for the monthly research newsletter, you can get updates as far as the cool things happening at the university and these news stories. And you can sign up for it at that URL right there. So how much time do I have?
None.
Yes! All right. If you guys want these later, just let me know and I'll give them to you. But with that, thank you.